geobyte.
Dear students, I hope all of you clearly understood all the theory concepts what we discussed for friction. Understood or not? Yes. Then let us discuss some previous year questions. Okay. Look at the very first question. Try to read it clearly. It is asking like this. A given object takes n times the time to slide down 45 degrees rough inclined plane as it takes the time to slide down an identical perfectly smooth 45 degrees inclined plane. One smooth plane is there, one rough plane is there. By the time the body is sliding down in the rough inclined plane, it is taking the time n times the time required for sliding down on the smooth inclined plane. But here, condition is the angle of the rough inclined plane and smooth inclined plane remaining same. Okay. The coefficient of kinetic friction between the object and the surface of inclined plane is you're asked to decide coefficient of kinetic friction. Okay. For that, look at the different options. Now let us consider T1 equal to time required time required for sliding down the object on smooth inclined plane smooth inclined plane of angle, right, of angle 45 degrees 45 degrees. Similarly, T2 equal to time required time required for sliding down the object. Object means same object on the rough inclined plane of angle 45 degrees. Okay. And the condition given is the time required for sliding down on the rough plane is n times the time required for sliding down on the smooth plane. Okay. For that, first let us take the smooth inclined plane. Smooth inclined plane. First let us take the base. This is the base. This is the plane. The angle between the base and plane is 45 degrees. The object may be somewhere here initially. The length of the let the length of the inclined plane is S1. Length of the inclined plane is S1. This is the length of the inclined plane S1. Okay. For this inclined plane, right? Inclined plane, let M be the mass of the object. Mass of the object. The acceleration A equal to G sine theta, that is 45 degrees. This is equal to G sine 45 degrees 1 by root 2. It is equal to G by root 2. That is the acceleration. Initially, let the object is at rest condition, means initial speed equal to 0. Then distance traveled by the object S1 equal to ut plus half at square. This is one of the equations of motion. Here u equal to 0. Here u equal to 0. Then S1 equal to half into a value g by root 2 into Here time taken is t1, t1 square. Let the a1 be the acceleration in the smooth inclined plane. So anyhow, the distance traveled by the object equal to gt1 square by 2 root 2. This is for smooth inclined plane. Okay. Similarly, let us take the rough inclined plane. Rough inclined plane. Rough identical inclined plane. The same angle and same the length of the inclined plane. Rough inclined plane. For this rough inclined plane, let us consider the base. This is the plane. The angle is 45 degrees. 45 degrees. Let us keep the object. Let us keep the object. Correct. Now the distance traveled by the object. This is the body or object. This is the body. Is S2. That S2 equal to S1. Identical inclined plane. Identical inclined plane means length of the inclined plane remaining same. S2 equal to S1. Let me write it clearly. S2 equal to S1. Okay. For this inclined plane, the acceleration is A equal to G sine theta, that is sine 45 degrees, minus mu G cos 45 degrees, cos theta. So G by root 2 minus mu G by sine 45 degrees and cos 45 degrees, both are equal. Sine 45 degrees is equal to cos 45 degrees, that is equal to 1 by root 2. So it is mu G by root 2. Root 2 can be written as G by root 2, G by root 2 into 1 minus mu. That is the acceleration, right, of the object in the rough inclined plane. Okay. Now, since S1 equal to S2, here S1 is equal to S2. Look at the S1 value. S1 value gt1 square for this you need to decide the S2 value. S2 equal to what? S2 equal to ut plus half a2 ut2 half a2 g2 square. Okay. U equal to 0. U equal to 0. Since u equal to 0, here S2 equal to half into a2 value g by root 2 into 1 minus mu into t2. But the t2 value n times the t1. That condition is given. It is n square t1 square. Now S1 equal to S2. S1 value is what? S1 value g t1 square by 2 root 2. Correct? Na? G t1 square by 2 root 2. Whereas S2 g 2 root 2 by 1 minus mu into n square into t1 square is equal to g by 2 root 2 into 1 minus mu into n square into t1 square. Now let us cancel gt1 square, gt1 square, 2 root 2. Finally it is 1 equal to 1 minus mu into n square. From this 1 minus mu equal to 1 by n square. From this coefficient of kinetic friction, 1 minus 1 by n square. This is the answer. Mu equal to 1 minus 1 by n square. Now look at the option. Look at the option. Look at the option C. Option C itself is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. Try to read it clearly. It is given like this. A car of 800 kg is taking turn on a banked road of radius 300 meters, and angle of banking is 30 degrees. Mass of the car given 800 kilograms. The radius of the curved path is 300 meters, angle of banking theta equal to 30 degrees. If coefficient of static friction is zero point 0.2, coefficient of friction is zero point 0.2, then the maximum speed with which car can negotiate the turn safely. It means what is the maximum safe speed to turn in the curved path. Okay. So the maximum speed V max equal to how much? The G value given, G equal to 10 meter per second square, and root 3 value also given. Root 3 value is 1.73. Okay. For that, let us mark the road in the curved, right? Curved, the outer edge is always at the high level compared to lower edge. This is the base. This is the outer edge. This is the angle of, right, banking. This kind of road is called banked road. Let me mark the car location. This may be the car location. Then this is the center of gravity of the car. Through the center of gravity, weight is acting vertically downwards. Now, normal reaction is always perpendicular to contact surface. Look at the contact surface. This is the contact surface. Normal to that contact surface. 1 minute. Normal to that contact surface. Normal to that contact surface. Normal reaction is developing. If I project the vertical line, if I project the vertical line, now this normal reaction is making an angle theta, an angle theta, right? Because this self weight is acting at an angle theta with respect to normal direction. Since the normal reaction is developing at an angle theta with respect to horizontal, it is developing two components of normal reactions. One is n cos theta, and perpendicular to that one, that is horizontal, this is n sin theta. N sin theta. Okay. Now look at the frictional force. Frictional force is always parallel to the frictional force always parallel to the plane. This is the frictional force. Frictional force direction with a magnitude mu n. Then that frictional force is making an angle theta with respect to horizontal. Then it is developing two components of, right, forces, frictional forces. One is mu n cos theta, right, in the horizontal direction, and in the vertical direction mu n sin theta, sin theta. Now look at the centripetal force Fc. That centripetal force and centrifugal force both are magnitude wise equal. It is mv square by r, mr square or mv square by r, where r is the radius of curvature. Okay. Now this velocity you are asked to decide. For that, I am going to resolve the forces vertically. Resolving the forces, resolving the forces vertically. Resolving the forces vertically means I am going to equate vertically upward forces with the vertically downward force. Look at the vertical upward force. Vertical upward force is n cos theta. Vertically downward forces are mu n sin theta plus mg. Mu n sin theta plus mg, plus mg. Okay. From this, I can write that n cos theta minus mu n sin theta is equal to self weight of the car. I'm going to write n cos theta outside. 1 minus 1 minus mu into sin theta by it is cos theta is equal to mg, or n cos theta into 1 minus mu tan theta is equal to mg. Let this is the relation number 1. Okay. Similarly, resolving the forces. Resolving the forces horizontal. I'm going to take the horizontally leftward forces to equate with the horizontally right side force. Horizontally left side forces n sin theta plus mu n cos theta. N sin theta plus mu n cos theta must be equal to Fc, that Fc equal to mv square by r. From this, let me write the n cos theta outside. N cos theta. N cos theta, then it is sin theta by cos theta plus mu, right? Plus mu is equal to mv square by r. It is n cos theta into, sin theta by cos theta, tan theta, mu plus tan theta is equal to mv square by r. Let this is the relation number 2. We got the two relations. I am using two relations for deciding the velocity. I am writing 2 by 1. 2 by 1. The 2 is what? N cos theta into mu plus tan theta. N cos theta into mu plus tan theta is equal to mv square by r. Similarly, the relation 1 is n cos theta into 1 minus mu theta. N cos theta into 1 minus mu tan theta is equal to self weight mg. mg. Now let us simplify it. N cos theta is cancelling. Of course, m also cancelling. Finally it is mu plus tan theta by 1 minus mu tan theta equal to v square by rg. From this v square by v square equal to, first let us decide the v square value. V square equal to rg times the mu plus tan theta by mu plus tan theta by mu plus tan theta, yes, correct, mu plus tan theta by 1 minus mu tan theta. Therefore, maximum safe turning speed v equal to root over rg into mu plus tan theta by 1 minus mu tan theta. So here r value given 300 meters. Substitute. G value given 10 meter second power minus 2. Mu value given 0.2. Theta value given 30 degrees. Root 3 value given 1.73 something. You substitute all values for getting the value approximately 51. Exact value 51.4 meter per second. Approximately 51, right? Exact value 51.4 meter per second. That is the safe turning speed, right? For the car, for avoiding the overturning of the car. Look at the options. Look at the options. Option B is absolutely correct. Understood clearly? Yes.
Geobyte.